Today we're going to be talking about how to find the unit tangent vector and the unit normal vector of a vector function. And in this particular problem, we've been given the vector function r of t is equal to, and here we've just been given the vector components t, 3 cosine t, and 3 sine t. Now, of course, sometimes you'll see this written instead as r of t is equal to ti plus 3 cosine t j plus 3 sine t of k, and of course those are equal to one another. It's the same thing. So whether you've just been given the components like this or you've been given the full vector function, either way we're just looking at those coefficients. Now, as a reminder, we have the formulas here for the unit tangent vector, which is going to be denoted by this capital T of t here. And as you can see, the unit tangent vector we find by taking the derivative of r of t, so we get r prime of t, and then we also are going to need the magnitude of r prime of t, which we'll talk about in a second. And then we have the equation for the unit normal vector, which we denote with this capital N of t. And it's really important to realize, of course, that the unit normal vector we're going to find with the unit tangent vector. So notice we have the derivative of the unit tangent vector and the magnitude of the derivative of the unit tangent vector. So obviously we're going to need to find the unit tangent vector before we can find the unit normal vector, since we use the unit tangent vector in the formula for the unit normal vector. So let's go ahead and start with the unit tangent vector. We can see that the first thing we're going to need is the derivative of r of t, which is r prime of t. So we can do it one of two ways. We can use this full vector function here and take the derivatives, or we can just use the components. Either way, we're just taking the derivative of each of these components individually. So let's go ahead and say that r prime of t is going to be equal to, we'll use the components since that's what we were given. So the derivative of t is 1. The derivative of 3 cosine t is negative 3 sine of t, because the derivative of cosine of t is negative sine of t. So we just pull that negative sign out in front of the 3, and the 3, of course, is going to stay. Then the derivative of 3 sine of t is 3 cosine of t, like that. So now here we have the derivative r prime of t. We're going to need that for our numerator. We're also going to need the magnitude of r prime of t, and the way that we find that, we denote it like this. The way that we find that is by taking the square root of the sum of the squares of each of these components. So all we're going to do is take each of these components, square it, add them all together, and put them under the square root sign. So squaring 1 here, we're going to get 1. Then we're going to add to that the square of negative 3 sine of t. Well, when we square that, the negative 3 times negative 3 becomes a positive 9, and sine of t times sine of t, we get sine squared of t. Then we're going to add to that the square of 3 cosine of t, which is going to be 9 cosine squared t, and all that's going to go under our square root sign. Now all we have to do is simplify this. So the first thing we're going to do is factor a 9 out of this sine squared t cosine squared t. So we'll get 1 plus 9 times the quantity, sine squared t plus cosine squared t. And the reason we do that, hopefully you've realized by now, is because we know from the trigonometric identity that sine squared t plus cosine squared t is equal to 1. So we can substitute for this whole value just a value of 1. 9 times 1 gives us 9. So then we just have the square root of 1 plus 9, or the square root of 10. Now, when we're talking about finding the unit tangent vector, we have the two components we need. We have the derivative of r of t, r prime of t, and we have the magnitude here of the derivative. So we're going to take this value here, r prime of t, these components, plug them into the numerator, and then take this square root of 10 and plug it into the denominator. So really, we just have this value right here divided by, if we just put a big division line, divided by this value right here in the denominator. But instead of writing it that way, we're just going to pull this square root of 10 out in front, and we're going to say that the unit tangent vector, capital T of t, is going to be 1 over square root 10, we pulled that out in front, multiplied by these components, 1 negative 3 sine of t, comma 3 cosine of t, like that, and that's how we'll define the unit tangent vector. when it comes to finding the unit normal vector, we're going to follow a very similar process because remember with our original vector function, we had r of t, we found its derivative and then the magnitude of the derivative. Well, now we have this unit tangent vector, capital T of t. We need to find its derivative and then the magnitude of its derivative. So we're just going to be starting with this vector instead of starting with this vector. So the first thing we need to do is find the derivative. So we'll say capital T prime of t is going to be equal to the 1 over square root 10 is going to stay out in front here. Now we just need to take the derivative of each of these components. So the derivative of 1 is 0. The derivative of negative 3 sine t, well, we know the derivative of sine of t is cosine of t. So the negative 3 is going to stay and we're just left with negative 3 cosine t. Now here the derivative of cosine t is negative sine of t. So we end up with negative 3 sine of t, and that is the derivative of our unit tangent vector, capital T prime of t. Now before we find the magnitude of this vector, we want to go ahead and factor out a negative 3 in order to simplify this as much as we can. Notice that we have a negative 3 in front of both the cosine t and sine t here, and if we factor out a negative 3 from the 0, we still just end up with 0. So we can say negative 3 over root 10 multiplied by the components 0, cosine of t, and sine of t. So that'll make it a little bit simpler to plug into our unit normal vector formula. Now we need to go ahead and find the magnitude. So we're going to say the magnitude of capital T prime of t is going to be equal to, again here we're going to do the square root. Now it's important that because this negative 3 over root 10 is multiplied by each of these components, we need to include it in our square root sign here. So we're going to square that as well because remember we're going to square each of these components and take the sum. So we'll say negative 3 over root 10 squared, and then we're going to multiply this by the sum of the squares of each of these. So 0 squared is just 0. I won't write that. Cosine of t squared is just cosine squared of t. And then sine of t squared is just sine squared of t, like this. I'm going to put it all under the square root sign. Of course, here I have cosine squared t plus sine squared of t, which is just 1. So since this is multiplied by 1, that can just drop away. Now when we square what we have left here, we're going to put that under the square root sign. We're going to get positive 9 in the numerator. In the denominator, we're going to get square root of 10 times square root of 10, or just 10. But of course, we still have to take the square root, so what we're going to be left with is just 3 over root 10. Now to find our unit normal vector, remember that we have here the derivative of our unit tangent vector divided by the magnitude of the derivative of the unit tangent vector. We found those two components. Basically, we're saying this value here divided by this value here that we just found. So as you can see, we have this negative 3 over root 10 in the numerator. We have this 3 over root 10 in the denominator. Those will cancel and we'll just be left with this negative sign here, the negative 1. So now instead of leaving this negative sign out in front, we can go ahead and distribute it across our components here. And we can say that the unit normal vector, we'll write it up here, n of t is going to be equal to, and we can just write the components like we just wrote the components for the unit tangent vector. We'll say 0, negative cosine t, negative sine of t. And of course we distributed that negative sign to the 0, but we can't write negative 0, so we just leave that 0 and we distribute the negative signs there. So we end up with an equation here for the unit normal vector and an equation here for the unit tangent vector. So that's how you find those two vectors for a vector function r of t.